Hello, welcome back to my second video on forces where I'm going to solve few problems related to Newton's second law. Okay, so what is Newton's second law? It is the rate of change of linear momentum that is proportional to the resultant force and is in the same direction as the force acting on it. Okay, so we can write our F net, the resultant force, to be the change in momentum divided by change in time. So this will give you equal to mass times acceleration. And the direction of acceleration is equal to the direction or same as the direction of the resultant force. Okay, let's start by solving the first question where we have mass of 2 kg, force 3.2 Newton, and a block experience acceleration 0.3 meter per second, and we want to find our coefficient of friction between the block and the horizontal surface. So first we sketch what is the forces acting on the object. So we have Fk, weight, normal, and the pushing force. And don't forget to write our acceleration that is moving to the right. Okay, so now we bring all the forces that we have sketched to free body diagram. So to sketch the free body diagram, we start by drawing a dot, okay, that represent the object. So we have weight downward, we have a force, friction force to the left, another pushing force to the right, and we have normal acting upward or perpendicular from the surface. Okay, so done sketching the free body diagram. So let's start by tabulate all the forces that we have. Okay, by referring to the free body diagram that we had just sketched just now, okay, so we need to list down all the forces that we have and need to have x and y component so that we can check either the force that we list have the x and y component or not. So we start with F. So F only have positive F at x component and 0 at y component. And for the friction, we have negative mu kn at the x component and 0 at the y component. Negative since it's directed to the left. Okay, and for weight, we have 0 at the x component but negative mg at the y component since it directed downward. And for normal, we have positive y and 0 at the x component. Okay, now we need to ask ourselves about the net force at the x and y component. Since the motion occurs at the x component, this means at the x component, we're going to have our acceleration. So ma, this is the Newton's second law, but at the y component there is no motion, so the net force at the y component going to be 0. Okay, done listing all the forces, so let's solve the first question where it asks to find the coefficient of friction. Okay, this means we want to find our mu k. So at the x component, we have our acceleration. So fx equal to ma, and we need to sum up all the forces at the x component. So we have 3.2 minus mu k times with normal force equal to 2 times 0.3. Okay, so we have mu k equal to 2.6 divided by n, and we label it as equation 1. Okay, so now we solve our y component, where y component fy equal to 0. So at y component, we have weight negative 2 times 9.81 plus with the normal force equal to 0. So we have our normal force to be n equal to 19.62 Newton. Okay, so that we label as number 2, equation 2. So now substitute 2 into 1, so we can get the coefficient of kinetic friction to be 0.13. Okay, so for coefficient of kinetic friction, there is no unit. Okay, so let's proceed with the second question, that is 2009-2010, where we have a block of mass 6 kg on a horizontal surface and coefficient of kinetic friction 0.22, but connected by a string, and put another block that has a mass of 3 kg. Okay, at first the system is at rest. So the question asks to draw the force acting on the block calculate the acceleration of the block and calculate the tension in the string. Okay, so we start by sketching the free body diagram for both of the objects. So this means we're going to have two FBD. Okay, so let's sketch for the first one. So it has kinetic friction, weight, tension, and normal. This is for M1. And for M2, okay, it's a hanging object. So we have weight, okay, downward, and we have tension upward. Okay, now let's tabulate all the forces. Since we have two objects, two free body diagrams, so I recommend to all of you to have two tables. Okay, so we have forces, x component, y component for both of the table. Okay, so let's start with the weight. So negative mg at the y component, 0 at the x component, and positive n at the y component, 0 at the x component. And for tension, it is positive tension since it's at the right, and the friction, since it's at the left, it is negative mu k n. Okay, so for tension and friction, both are 0 for the y component. Okay, so check at which component there is a motion. So the motion is at the x component. So F net, so x component going to have m1 times with a, but for the y component, the net force at y component will be 0. Okay, so let's do the same thing for our second object. Okay, where the force acting on the object is weight and tension. So weight is negative at y component and tension is positive at the y component. So for this part, x component there is no motion, but at the y component we have a downward motion. So this means our acceleration going to be negative a. Okay, so let's find our acceleration. If the object is connected by one string, this means both will moving with the same acceleration. So we use Fx equal to m1a. So sum up all the forces. So T equal to mu k times with n equal to m1a. And we substitute the value of mu k and also the value of mass. So we let it as equation number 1 and proceed with Fy equal to 0. So we have negative m1g plus n equal to 0. So rearrange, we get n equal to 5.87 Newton. That is equation number 2. So substitute 2 into 1. So we get tension to be 0.22 times 5.87 plus 0.6 A. Okay, so now we have two unknown that we need to solve. Okay, so proceed with the second object, where we have Fy equal to negative m2a, the negative since the object is moving downward. So substitute all the information and we get the fourth equation. So substitute fourth in the equation into equation 1. So we get A equal to 1.84 meter per second square. Okay, the third question asks to find tension. Okay, so we substitute the value of A that we get into the first equation. Okay, so we get T equal to 1.9 plus 0.6 times 1.84. So we get the value of T to be 2.39 Newton. Okay, so that's all.